Hi everybody, hi, welcome back. We're getting back to the material and we're going to talk about light and energy, wavelength, frequency. Question of the day is, what is the wavelength of a photon emitted by a hydrogen atom when its electron relaxes from n equals 5, now those are quantum numbers in quantum levels, shells where the electrons can exist. When it relaxes, that means going from higher to lower, n equals 5 to n equals 1. And this was something pioneered by Bohr and company, who figured out the Bohr equation, which is an inverse square law, which is the energy is proportional to a constant times 1 over n squared final minus 1 over n squared initial.
Hey, Dad.
And so we can, yeah, sorry, that's my kid. What?
I know it's really late at night, but
It's getting late, man.
I looked on the front porch and someone left a bag there and it smells smoky.
There's a smoky bag on our front porch, then.
I don't know.
Okay, well just let it, well, then, yeah. You got it in your hands?
No, it's right here.
What are you doing? It's smoking.
It smells really bad.
It smells bad and it's smoking.
I don't
And
deal with it. Just
no, they don't. I'm glad you didn't step on it. That's just what they want. Look, I gotta cut this part out, okay? Like, why don't, here, just let it smoke out. Sorry about that. So let's, oops, sorry about that. So let's plug in. Final is where the electron relaxes to. That's gonna be 1 squared. Initial, that's where the electron comes from. It's going to be 5 squared. Let's plug it in and do a little bit of algebra. Here we go. So anyhow, energy equals to negative 2.18. By the way, I'm going to get rid of that negative because you got to remember what they're asking for. They're asking for a wavelength. There's never a negative wavelength. So this negative is there because a falling electron is an exothermic process. So we're going to go ahead and just not worry about negatives and positives yet. Next example we do tomorrow will. So divide times 1 over 1 squared minus 1 over 5 squared. That ends up being obviously 1 over 1 minus 1 over 25, which is times 1 minus 0.04. That is the energy of one photon that falls from quantum level 5 to 1 in hydrogen. And now we got to employ the use of our equation to find frequency and then wavelength. So E equals H times frequency. Let's go find frequency. Frequency equals E divided by H. And the H constant is, so 2.0928 times 10 to the minus 18 joules divided by what we call Planck's constant, which is 6.63 times 10 to the minus 34 joules times seconds. And we'll get our frequency. It will have units of joules. We'll cancel inverse seconds, which means waves per second or cycles per second. There's our frequency. If you don't get that number, watch out. You might be doing something wrong in your calculator. Comment or message me if you're not getting the correct number. It's a power of 10 issue. Now, that's frequency. We need to find the wavelength using the relationship of wavelength times frequency is speed of light. That means wavelength is the speed of light divided by frequency. Speed of light is 3.0 times 10 to the 8th meters per second. Our frequency we just determined is 3.1566 times 10 to the 15 inverse seconds. Now let's find out what that is. And the result of that calculation is 9.504 times 10 to the minus 8. The units are meters because inverse seconds cancel. Now I don't really have a good frame of reference for where that is in the range, so let's convert it to nanometers. 9.504 times 10 to the minus 8 meters. 1 meter is 10 to the 9 nanometers. That'll end up being 9.504 times 10 to the negative 8 plus 9 equals positive 1. That means 95.04 nanometers. That's our answer. Where's that? Well, the visible range is from 400 to 700 nanometers. This is lower than 400 nanometers, which means it's larger in energy than the visible range. This is UV light. Even though that transition is very possible, you can't see it with your eye outside of the visible range. More tomorrow. Hang in there, guys. Hope you're loosening your mind synapses as you get back into the swing of things. All right. Bye.